we've done this so many times when we factored. You have 2x equals 0 and you have 2x minus 9 equals 0. You solve both. So there are, how many answers are there? Well, there's one here. There's the 0. There's 0. X equals 0. And then you have x squared equals 9 over 2. So you do the square root of both sides and you end up with two answers, plus or minus 2.1. Plus or minus 2.1. Plus or minus 2.1. So you get the sign diagram, negative 2.1 and 2.1. So there are, and there's a 0 in the middle. So how many regions do you have? How many regions do you have? How many regions do you see on the sign diagram? 1, 2, 3, and 4. You're going to have to test points. So maybe negative 3, maybe negative 1, 1, and 3, and come up with the sign diagram. The only difference here is that the zeros aren't quote-unquote nice. The only difference here is that the zeros are. On this question, where did the graphing calculator get used so far? Here. Sorry, you can't see that. Sorry. It's getting used where? Here, and where else? There. Right there. Because they wanted to get a decimal equivalent right there. That's the only thing the calculator is being used for at this point. If you actually group this out, you get x squared, x minus 1, minus 5 times x minus 1. So you end up with x squared minus 5 times x minus 1. What are the 3 zeros on this? There's 3 of them. What are they? 1 is one of them, but what? Yeah? Positive what? Yeah, root of 5 and? Negative root of 5. Henry asked a really good question, which was, if you factor out something, do you have to keep that when you take the derivative? The answer to that, Henry, is yes. If you factored out, let's say this had like a 2 in front of it, do you get to ignore the 2 when you take the derivative? Be careful, don't ignore the 2. You need to keep that 2 in there. So when you take the derivative, what do you take the derivative of? The original function. So when you take the derivative of the original function. The key is do it piece by piece. Do it piece by piece. Do it piece by piece. So there's this statement right here, which is the theme for today. Something we've talked about before. How many people have seen S, V, and A in another class? How many people have seen those letters before? Position, velocity, and acceleration. Does anybody remember why S is used for position? Anybody take Latin? Is there Latin somewhere in there? I don't know. These are the names here, but what are the relationships? The rate of change of position will be velocity. The rate of change of velocity, so S double prime, will be acceleration. So what does that mean? Well, it means that we can answer questions like this. We can answer questions like this, everybody. Fantastic. Bill is walking along a straight east-west path. Below is a graph that gives Bill's distance. I can't emphasize this enough. This entire question revolves around the fact that this graph right here is a graph of what? Distance. It's distance. If I change that to velocity, does it change all of these questions? Yeah. So if you misinterpret this, all of the questions here get all like shifted. You have to be very careful about this. Positive is to what direction? East. East is positive. So a question I have for you, first one is, during what time intervals is Bill walking in an easterly direction? Meaning, when is he moving in a positive direction? How do you figure that out? When will he be moving in a positive direction? If S of t is his position, he's moving in a positive direction when?
When y is positive.
No. He's not necessarily, right? If he's like, he could be to the left of home. When what?
X is greater than 0.
Not necessarily, because he could be moving back and forth, right? When what?
When the slope is positive.
When the slope is positive. So when the what is positive? The derivative of position is positive. So in this case, the position is S of t. So this is when S prime of t is what? Greater than 0. Let's take a look at this. This is the position graph, remember. This is S of t right here. So where is the derivative positive? And what color did I use for that? I used yellow for that, I think. Where's the derivative positive? Where's the derivative positive? From what to what? Where does it, from 8 to, and let's say it stops right there at, let's say 16. 16. So where is he moving in an easterly direction? When the derivative is positive. So what interval is that? From 8 to what? 16. When I give you questions like that, like this, and I don't give you the function, you can estimate. So some of you might say 8, some of you might say 8.1, right? The point is, you don't know exactly what it is, but this value, what x value is this about? About 8. Don't worry about sitting there going, is it 8.1 or 8.2 or 7.9? Just pick 8. And if I don't have arrows, it's stopping there. I'll try to be more explicit. So during what time interval is he walking west? When is that happening?
0 to 8.
Ah, when S of t is what?
Oh.
Less than 0. So I'll use blue here. So 0 to what, Kira?
To 8.
0 to 8. Exactly. It looks what? It looks steepest, right? From here to here, it looks like it's getting steeper, right? And from here to here, what does it look like it's doing? Less steep, right? So where does it look like it's steepest? At time equals 12. Why not here? I have a question, Jen. Why didn't I say here? Isn't that pretty steep?
Yeah.
But the velocity there is what? Negative. Here, v of t is less than 0. So for greatest, can velocity have a sign? Yes, because velocity has a direction. Because velocity has a direction. But hey, what did we find out? What's the next question asking? When is the velocity least? Did we answer that?
Mr. Seaman?
Yes.
Why didn't we choose 4?
Does speed have direction? Speed is either 0 or what? Give me a speed. Positive, exactly. Speed is always 0 or positive. So what's the relationship between velocity? If I went 10,000 miles an hour to the east, my velocity would be plus 10,000 miles. If I went 10,000 miles an hour to the west, my velocity would be negative, right? But in both cases, what's my speed? 10,000. How do you turn negative 10,000 into 10,000? That's called the, it's called the what?
Absolutely.
Yes. So what is speed? Speed is what? The absolute value of velocity. So where is speed greatest on this? And there can be more than one answer. Least. In this case, if there's a 0, 0 is the slowest speed, correct? So is there one place where that happens? Where does that happen? 8. Because what happens at 8, Calvin? Say it, what? The slope is 0. The slope of the tangent line is 0 when t is 8. Now I have a question here. Does a particle always have to stop moving? In this case, this particle, this person stops moving at time equals 8. Is it possible for a particle never to turn around or just keep moving forward? Is that possible? Yeah. Could I have a position graph that does this? Like this? Where would the speed be least here? Where would the speed be least here? Somewhere where? Yeah, like right here, right? Because it's like the least steep right there. So in this case, it's 0. Yes.
Right, okay.
You got it?
Yeah.
But in general, if there's going to be a maximum, if there's going to be like peaks like this, what are you looking for? It's the speed is 0 there. Okay. The second derivative. So that's s double prime, which is acceleration, right? Positive means what? What does that mean in terms of the structure of the graph? Positive acceleration means what? Concave up, which means acceleration has to be what? Greater than 0, which is s double prime is, it's all the same thing, right? So that means concave up. So looking at this graph right here, what did I use? Green for concave up? Where does it look like it's concave up if you had to estimate where it's concave up from? Where does it look like it's concave up? 4 to what? To 12, right. So it's concave up from 4 to 12. So the second derivative is going to be positive from 4 to 12. Where's it concave down? 0 to 4, and where else?
12 to 16.
12 to 16. 0 to 4, and union 12 to 16. This is when the second derivative is what? Less than 0, which is the same thing as acceleration because they're the same. Are we okay so far? Just checking in. 8 to 12. So is it's speeding up from 8 to 12. That's both the s of t and a of t are both what? Positive. But it's also true when s of t and a of t are both what? They both could be negative. So what are the colors for negative here? Where's the negative slope? That's negative slope is blue.
We need the 4 too, right?
Ah, close, careful. We know it's 8 to 12, green and yellow, right? So where are they both? That's when they're both positive. What about both negative? Meaning negative slope is blue and concave down is purple. So where is it blue and purple? Where is it blue and purple?
0, 4, 0.
0 to, yeah, go from the left to the right. 0 to what?
0 to 4.
0 to 4. So there are two places where it's speeding up. Where is it speeding up? 0 to 4 and
Oh, so that was negative and negative.
negative and negative, or positive and positive. So then there's two cases over here where s of t is less than 0. Sorry, it's not s, it's v. Sorry. It should be v of t. Sorry. And it's not s of t. It's what? It's v of t is less than 0. So if it's slowing down, what does a of t have to be? Positive or negative? Does it have to be positive or negative now? No, because if it's slowing down, it means they're opposite signs, so this is going to be positive. And what's the other case? V of t is greater than 0, and a of t is what? Less than 0. So where are they opposite signs? That would be blue and green and purple and yellow. Blue and green and purple and yellow. So when is it blue and green? 4 to 8. 4 to 8. And when is v of t positive and negative? Oh, 12 to what?
16.
12 to 16. So if you wanted to write the proper answers, you would say 0, 4, union 8 to 12. And then for this one, what would you write? 4, 8, union what? 12, 16. Yes. Only difference now, everybody. Velocity. This is the velocity graph. So this is what I'd like you to do. Please try doing A through D by yourself on this one. Try doing A through D.